Hello viewers, in today's class we are going to discuss some important problems from indefinite integrals, right? And we'll take some problems from indefinite integrals in which we will make use of the method of substitution, right? So let us take the problems one by one. So let us take the first problem, that is integral of square root of e raised to x minus 1, right? So we call this integral as I, and now see here our integrand is in the form of square root, right? And inside the square root sign we have e raised to x minus 1. So what we will do, we'll take the parameter, or we will introduce the variable t as square root of e raised to x minus 1, right? So we'll take this substitution, that is we'll put t is equal to square root of e raised to x minus 1. Now if we take the square of both sides, see what we get. We get t square is equal to e raised to x minus 1, right? Okay, so now we have t square is equal to e raised to x minus 1, and let us differentiate both sides with respect to x, right? So if we take the derivative of both sides with respect to x, then we have this expression, right? Okay, now the derivative of t square with respect to t is 2t, and then by chain rule we'll have dt over dx, right? And here the derivative of e raised to x is e raised to x, and the derivative of 1 is 0, right? So now see here we have e raised to x. Now from this equation we can write e raised to x as t square plus 1, right? And we'll substitute this value e raised to x is equal to t square plus 1 over here. So we'll have 2t dt over dx is equal to t square plus 1, and we can also write this as 2t dt is equal to t square plus 1 dx, and dx can be written as t square plus 1, here we'll have 2t dt over t square plus 1, right? So now we have the value of dx in terms of t, right? Okay, now let us come to our integral. Now here I can now be written in terms of t as when t square is equal to e raised to x minus 1, then t is equal to square root of e raised to x minus 1. So we can write here t, and for dx we can write 2t dt over t square plus 1, right? Okay, so now we can simplify it. So this is 2t square, 2t times t is 2t square over t square plus 1 dt, right? So now we see here that 2 is a constant, so we can take it outside. So we have 2 times t square over t square plus 1 dt, right? Okay, now here we have to apply a simple method, that is see here we have t square, and in the denominator we have t square plus 1. So what we will do, we'll try to create a term t square plus 1 in the numerator, right? So we can write it as like this, t square plus 1, then we can take here minus 1, right? So what we are doing here, we are trying to create a term t square plus 1 in the numerator, right? So t square plus 1 minus 1, because 1 and 1 get cancelled, and again we'll get t square. So now we have this expression, right? Okay, now see if we group t square plus 1 as one term, and if we split this expression from here, then we can write integral t square plus 1 over t square plus 1 minus 1 over t square plus 1, right? Okay, so now here t square plus 1 and t square plus 1 get cancelled, so we are left with 2 times integral of 1 minus 1 over t square plus 1 dt, right? And now we can simply write this expression as 2 times integral of 1 dt, then we have 2 times integral dt over t square plus 1 and plus c, right, where c is the constant of integration. Okay, so now we have the integral of dt as simply t, and the integral of 1 over t square plus 1 is simply tan inverse of t, and here we have the constant of integration, right? So here we have used the result, that is the integral of 1 over x square plus 1 is equal to tan inverse x, right? So now we have the value of this integral in terms of t as 2t minus 2 times tan inverse t plus c, and now we can express this result in terms of x, right? So now writing the value of t as square root of e raised to x minus 1 over here and here, we can finally write the integral as 2 times square root of e raised to x minus 1, then we have minus 2 tan inverse of square root of e raised to x minus 1 plus c, right? So this is the final value of the integral of this function, that is square root of e raised to x minus 1, right? So now let us take the second problem. So now here we have this problem, that is we have to find the integral of e raised to x divided by 1 plus e raised to x square, right? So let us call this integral as I, right? So again we'll take the help of substitution method and see that here what we will do, we'll take 1 plus e raised to x as t, right? So we'll take this substitution here, because when we differentiate t with respect to x, see what we will get. We'll get dt over dx is equal to e raised to x, and see the derivative of 1 plus e raised to x is e raised to x, which is present in the numerator, right? So the proper substitution would be t is equal to 1 plus e raised to x, right? So now dt can be written as e raised to x dx, and for this term we can take dt, right? So we have dt divided by 1 plus e raised to x whole square. So for 1 plus e raised to x we have t, so we'll have t square, right? Now we have a very simple integral here, so we can write t raised to minus 2 dt, and now we can make use of this result, that is integral of x raised to n is x raised to n plus 1 over n plus 1, provided n is not equal to minus 1, right? So here we have n is equal to minus 2, so we have t raised to minus 2 plus 1 divided by minus 2 plus 1, so we have t raised to minus 1 over minus 1, and that is minus 1 over t plus c, right, where c is the constant of integration, right? And now we can resubstitute the value of t as 1 plus e raised to x, so we have minus 1 over 1 plus e raised to x plus c, right? So this is the final value of the integral of this function, right? So now let us take this problem. Here we have to find the integral of this function, right? X plus 1 e raised to x, then we have sine square x times e raised to x, right? So here what we will do, the appropriate substitution would be t is equal to x times e raised to x, right? Because see here x times e raised to x is the product of two functions, right? And from the theory of differentiation we can realize that the derivative of this function, that is x times e raised to x, is present in the numerator, right? So what we will do, we'll find dt over dx, and here we'll make use of the result, that is the product of two functions, that is the derivative of the product of two functions is given by first function, that is u, then we have dv over dx, then we have v, and then we have du over dx, right? So here we can take x as u and v as e raised to x, right? So this is x times derivative of e raised to x, then we have e raised to x and derivative of x, right? So we have x, e raised to x, the derivative of e raised to x is e raised to x, here the derivative of x is 1, so we have e raised to x times 1, and now if we take e raised to x common, we have x plus 1, right? And see here x plus 1 e raised to x is in the numerator, right? So whenever we come across with such problems, then we should always try to take that substitution in which the derivative or some terms in the derivative occur in the numerator, right? So now we have dt over dx as this term, so dx e raised to x, x plus 1 dx is equal to dt, right? So now this integral takes the form, we have for this term we have dt, and see here we have sine square, and for x e raised to x we can write t. So now we can take 1 over sine square t as cosec square t and dt, right? And from the standard results from the integrals, see the integral of cosec square t is minus cot of t, right? And c is the constant of integration. And now we can resubstitute the value of t as x times e raised to x, so we have minus cot x e raised to x plus c, right? So this is the final integral of this function. So now let us take this problem. So here we have to find the integral of sine 2 plus 3 log x divided by x, right? So now we can take this integral as I, and see the derivative of log x is 1 over x, right? The derivative of log x is 1 over x. So now we can take here t as 2 plus 3 log x, right? Because when we differentiate t with respect to x, then the derivative of 2 is 0 and the derivative of log x is 1 over x, and see here x is present in the denominator, right? So let us differentiate t with respect to x. So the derivative of 2 is 0, and here we have the derivative of log x as 1 over x, so this is 3 over x, and now we can write dt over 3 is equal to dx over x, right? So here for dx over x we can now write dt over 3. So now I can be written as integral, and we have sine of t, because 2 plus 3 log x is t, so we have sine t, and for dx over x we have dt over 3, right? And 3 is a constant, so we can take it outside the integral sign. So we have now integral 1 over 3 times integral of sine t and dt, right? And from the standard results we know that the integral of sine t is minus of cosine t and plus c is the constant of integration, right? And now we can resubstitute the value of t. So we have 2 plus 3 log x, so we can now write minus 1 over 3 cos 2 plus 3 log x plus c, right? So this is the final integral of this function.